Uh, Guys, in this video we will discuss about the curve fitting. So first we have to know that what is curve fitting. The general problem of finding equation of approximating the curves which fits the given data is called curve fitting. So now let us elaborate the concept of curve fitting. So first of all, to find the or to distinguish the define the curve fitting, first we have to consider n pair of values. Like we consider x1, y1, x2, y2, and x and y of two variables x and y. Now, to get a rough idea about the relationship, if any, that means we have to find the or we have to estimate the rough idea about the relationship between the two variables x and y. Here we consider, then we have to on a suitable scale, and then the points xi and yi constitute a diagram which is known as a scatter diagram. And now an exact relationship between the variables x and y, that is, suppose y is equal to f of x, which fits the given sets of data, is called curve fitting. And now here there is something we have to know, that generally it is not possible to find a curve which passes through all the given points, and we can obtain the relationship between x and y in the form of straight lines, curves of second degree, third degree, and which may give the best representation of the bivariate distribution. And for this we can use that for a given set of pair of data, we can use the method of least square to get that representation. So now that means whatever we that for a particular set of data, or that is the n pair of data, we can feed them in the form of straight line, curves of second degree, third degree, or etc. That will be chosen by the observer, and generally it is not possible to find a curve which passes through all the given points, and actually it can be more visible if we can use all the data into the Excel software or anything like Zamovi and SPSS. So now here we discuss about the principle of least square. That is, let a set of n points we consider here, and here we consider that capital Y be the expected value of small y corresponding to x is equal to xi, and whereas small y is the observed value of y corresponding to x is equal to xi. That means for a random experiment, suppose if x is the independent variable and y is the dependent variable, then something we expect but something we get that is different. So that's why the dependent variable is since y, so capital yi is denoted by expected value and small y is the observed value, and in general small yi not equal to capital yi, and this difference between the observed value and the expected value is called the error of estimate or the residual of y, and this is denoted by ei, and whereas ei is equal to small yi minus capital yi, where capital yi also is a function of x. So now some errors ei will be positive and other negative. So to give the equal weightage to each error, we square each of these. So what we get? E is equal to I is equal to 1 ei square. And now if e is equal to 0, that means if there is no error, then all the points lie on the curve, and if otherwise the minimum of e gives the best fit curve to the data. Okay, that means if e is so see here that first what I say, that if that generally it is not possible to find a curve which passes through all the given points. That means, and see here, and here if we find that sum of the all error will be 0, then we can say that all the points lie on the curve. So this is a method that if e is equal to 0, then we can say that all the points are on the curve. Otherwise, the minimum of E gives the best fit of the curve. Actually, what I say, there's the curve of the best fit is that for which the sum of the squares of the error is the minimum. And what I say that we can find the best fit of curve by using straight line or second degree curve or third degree curve. So here first we will choose that if we want the best fit curve is a straight line. So how can we obtain that straight line? So let us see. So see here that we consider that the best fit of curve is of the form straight line y is equal to a plus bx. So here E1, that means we can write y1 minus capital Y1, and capital Y1 here is equal to a plus bx. So here write a plus bx1, this is E1. Similarly E2 is equal to y2 minus a plus bx2, and so En is equal to yn minus a plus bxn. So now according to the principle of least square, we can write that E1 square plus E2 square plus E3 square plus En square is equal to E say. So here we can write E is equal to EI square, I is equal to 1 to n, and EI means here we can write yi minus a plus bxi whole square, or simplifying we get I is yi minus a minus bxi whole square. So now since this is a bivariate function, so we have to find for maximum and minimum, that already we know from the second semester syllabus that we have to and here a and b are the variables. That means we have to determine a and b for finding the best fit of curve. So here we have to obtain that del e del a is equal to 0 and del e del b is equal to 0. So let us see what we get. That is, if we differentiate partially with respect to a, so what we get? 2 into yi minus a minus bxi, and the derivative, partial derivative of minus a is minus 1 is equal to 0. And here if we simplify, we can write yi is equal to summation of I a plus bxi, and if we more simplify, we get I is equal to 1 yi is equal to a into summation over I is equal to 1 to n, so this is na, plus b into I is equal to 1 xi, this is 1, we denote it 1, and del e del b is equal to 0. This implies 2 into summation I is equal to 1 to n yi minus a minus bxi, and the derivative of minus bxi with respect to b we get minus xi, and if we simplify, we get I is equal to 1 to n xi yi is equal to a into I is equal to 1 to n xi plus b into I is equal to 1 to n xi square. And now solving this 1 and 2, we get the best fit of the curve as a straight line, and these two equations are known as the normal equation. These two equations are known as normal equation. And so now this is so for finding the straight line of a as a best fit curve, we have to know these two formulas, that is summation yi I is equal to 1 to is equal to na plus b into I is equal to 1 to n xi, and summation over I is equal to 1 to n xi yi is equal to a into summation I is equal to 1 to n xi plus b into I is equal to 1 to n xi square. These two equations are known as normal equations, and after solving this, we have to find the value of a and b, and then we put the value of a and b here, and we get the best fit of the curve for the corresponding set of pair of data. So now let us see one problem about this. So here we check the problem that by the method of least square, find the straight line that best fits the following data. So here this is the given data, that is x is 1 2 3 4 5 and y is equal to 14 27 40 55 68. This is a very easy problem, that is we have to just know the normal equations. So since the given that we have to find the best fit curve is a straight line, so we take the line is y is equal to a plus bx, and the normal equation is of the form yi is equal to na plus b into summation over xi, and summation xi yi is equal to a into summation xi plus b into summation xi yi square, whereas I is equal to 1 to n, I is equal to 1 to n. So now we have to solve these two equations with using these two data. So what we want here, that we need y, x, xy and xi square. So for solve this two equation, we just construct here a table. That is the table of summing x, y, xy and x square. So we put the values of x here in the given question, and also y is given in the question. So put all those values. Now we have to find the xy. Xy means the product of x and y. So we get xy is 14, this is 54, this is 120, this is 220 and this is 340. And x square means 1 square 1, 2 square 4, 3 square 9, 4 square 16, 5 square 25. So summation x is equal to 15, summation y is 204, summation xy 748 and summation x square is 55. And see here the total number of pair 1 2 3 4 5. So here n is equal to 5. So we put all the values in the equation 1 and 2. We get 204 is equal to 5a plus 15b, and 748, that is summation x, summation xy 15a, 15 means summation x, and just put all this value here, and summation x square is 55b. And now if we solve it by using the cross multiplication, we get here a is equal to 0 and b is equal to 13.6. So we can write now the best fit of the curve is of the form y is equal to 0 plus 13.6 into x, or y is equal to 13.6x. So I hope you understand that how can we find the straight line as the best fit curve. So thank you.